Is there going to be both?
Oh, yes. Well, 8 ohm. We might have to come back on Wednesday and finish it.
Why can't we finish it tomorrow?
Well, we'll be doing stuff tomorrow. I'm trying to get another class out of you guys.
No, I mean, we can finish this problem tomorrow, and then we can start some other lengthy problem tomorrow and finish it on
Yep.
Wednesday.
I'll go like this. There's this.
For the rest of the year, we're done. We're going to class every day. Can
Can we just cancel physics for now? I think we all work hard enough, and we'll just take all that time for circuits.
If you solve one of these unit problems, you get to omit the problems.
Look at this, I made like generating.
That's right.
I don't know, it's Sprite with some Pepsi mixed in.
It's Prepsy.
It's still Sprite. Water with salt in it is still water.
Here we go. Let's put some numbers like normal numbers. 6.4 millihenry.
Yeah.
Thanks, that's 0.4 millihenry does not look like a normal number. Might be a normal range.
Here we go.
I guess.
Why isn't there an op amp in there?
So we did the op amp last time. 6.25 microfarad. We could get crazy with it, but that's plenty. Plus, minus, I'm looking for V out. Again, I have no clue how bad this problem is going to turn out to be or how easy. No idea if the math is going to be really ugly or not. The good news is it's not going to be that bad because this source is a constant. If that was sine or cosine, I know the Laplace of that. You know, if that was sine 9t, for example, then it would be what? 9 over s squared plus 9 squared. So it makes the math a little bit more complicated. So having just a DC value like this, not a bad idea.
So what's going on with the switch?
The switch is connected like this, and at t equals to 0 switches to that.
Okay.
And I want to find what V out as a function of time. And again, no idea what's going to happen here till we go through it.
Is it, it's been sitting there?
Yeah, it's been sitting for a while. Somebody came in last night, connected it. Todd, he has nothing to do. He was working with Professor Washburn, went to the lab and built that one for us.
Oh, nice.
And that was yesterday. Today, when you go to the lab to see Professor Washburn, oh, by the way, that circuit was connected. Let's analyze it. Now, again, let's look at the circuit for t less than 0. That means this piece was open. So here's my circuit. And it really doesn't matter if I flip-flop these two or not. I'm not a fan of putting the 8 here and this one here. I like it backwards, so I'll reverse it. I always like my source at the beginning. Why? I don't know. I have a little bit of OCD in me. There's different things that bothers me. You know, I got to make sure they're in the right order. It's just the way I like them. I never like to start a quadratic equation with a negative value. You will see I'll change everything to plus. I just don't like it. This is 80. This is 20. This is going to behave as short circuit. So I need to know what is the current through the inductor is 0 minus. And what's going to happen to that capacitor? Open circuit. And what's the voltage across the capacitor is 0 minus. I can find the equivalent of these two, the parallel combination, right? The product over the sum. So that'll be what? 8 times 80 over the sum of them, which is 88.
Yep.
That's 80 over 11. That's not a good number. Should we write 80 or just use, I'll use decimal. Clear, let me get out of this escape. Got it. Escape, quit, whatever, get out of this, yep. $80 divided by 11 is 7.27. So my circuit now will look like this. I should have did source transformation, but that's okay. I don't need it. This is the 20 VC. I can tell you what this current is, I sub L 0 minus. Actually, I'm glad I didn't do source transformation, because I can do current division here. Is equal to the source. If I'm looking for the current going through that 20 ohm, I got to use this one. The 7.27 divided by what? The sum of them, 27.27.
No, aren't those in parallel?
Those two in parallel, yeah. So this, the current, times that over the sum of them. Times 9. You probably did that in physics too, right?
Yeah, I did in the test.
Was it?
Oh, I did voltage.
2.4.
I did some kind of division.
Yep. If you know what the current, can you find the voltage across the capacitor is 0 minus? Notice that's the voltage across the 20 ohm resistor. So 20 times the 2.4. Is that a 48?
That number worked out well.
Yep. Luck.
Not looking so bad yet.
Yep. I took a couple of problems from the book, actually. This was one problem, and I added these pieces to it from a different book. Makes it more fun that way. So now we're going to look at the circuit for t greater than 0. So for t, the switch is going to move down here. That means that 9 amps is going to circle right here. Can you see it? That's open here. So it's really, I'll draw it actually. This is what it looks like. It has nothing to do with it because it doesn't do anything here. Uh-oh. I just noticed another thing. Is that what we have? Now, that 9 amp has nothing to do with the right side of the circuit. Because circle's right there. Doesn't do me any good. So I can even cover it. Look at that. These two in parallel. What's the equivalent value for them? 0. Right? So what you have is this now. That's what you have.
Do we have to change that inductor to have a source or no?
Well, now once I switch to the S domain.
Oh.
So that's my circuit and time domain. Now let's go to the S domain. I got to find the Laplace of them. I already forgot this has an initial current going through it of what? 2.4? And the voltage across the capacitor was plus to minus on the top of 48. We'll see how they're going to come in. So let's look at the S domain. Where is my problem? Here we go. when you have a capacitor, you have two options for the capacitor. You can replace it with 1 over SC with the voltage source. I don't know if you can read it or not. The value of that, V of 0 over S. Or you can replace it with the current, like a capacitor with the value of SC here, with a current pointing upwards, C times V sub 0. So let me try the first one. I'll do the first one. So the capacitor, I'm going to replace it with 1 over SC. I'll come back, put the value, with a voltage source the same direction of the value of V of 0 minus over S. The resistor stays the same. The Laplace of R is R. The inductor. Here's my inductor. I'm going to replace it with SL. And here's the inductor. I can replace it with SL and a voltage source, if you want here, of the value of L times I sub 0. So minus to plus. Oh, I just said minus to plus, and I started writing a plus.
The opposite direction.
Huh?
It's going in the opposite direction.
Yep, minus to plus. And if you look here, Eli, just like the current here, when we do that, the current pointing in the same direction, where plus to minus, the current's down. Here, the current's going backward. Again, the reason why one this, one that is the derivative, the Laplace of the derivative or the Laplace of the integral. This is the current. The same thing. V equals L di dt. The voltage is the Laplace of the derivative. So that's why you get V of 0 plus to minus V of 0 over S. I know I can't zoom in on it. Oh, I mean down here? Yeah. So anyone watching the video, I'll say freeze it and write these somewhere down. And that's the Laplace of the derivative. That's the Laplace of the integral. Why? Because I equals 1 over C, the integral of V dt. And that's the Laplace of the integral. V equals L di dt. That's the Laplace of the derivative. Again, you can find the current. You can find the voltage here. So once you have these two, what was the question? Initially, I forgot.
You wanted I sub 1.
Which is right here. Right, V out. Was it cross the inductor? Yep. So that's really V out right here. So that is my circuit now. Let me just plug in the numbers, put in some numbers in it, and I'm in business. My number is going to be ugly. So 1 over SC, we know C is 6.25 micro. What is 1 over 6.25 micro? 1 divided by 6.25 EE, where's the E? To the negative 6. Oh, look at this, 160,000. So that would be is it 160,000? It is 160,000. 160,000 over S. A value here of VC. That wasn't that 48 when we did the math? 48 over S. What was that resistor? 20 stays 20. That inductor, SL. L is 6.4 milli. EE, where's the E? Negative 3. That's 0.0064 S. I don't like the 6.4 milli. I will lose the milli eventually, the little m. And I'm going to have a voltage source here of L times I sub 0. We know I sub 0 for that was 2.4. What's 2.4 times L? And I got 0.01536. Hopefully my numbers are good. And this is my V out. Now I can put all the stuff away I had here. And I'll just throw currents. Maybe I'll do, I don't know, I sub 2, I sub 1, doesn't matter what direction you throw them, doesn't make any difference. And I should have two equations by two unknowns. How ugly the math, we'll find out soon. KVL right here, that's a source. Entering that, that's a negative. 48 over S plus 160,000 over S times I sub 1 plus 20 times the current going to the right, I sub 1 minus I sub 2.
Is it a plus?
Plus, yeah, thank you. They both go in the same direction. And I gotta clean it. If I multiply by S and I move the 48 there, I will have 48 equals 160,000 I sub 1 plus 20S times I sub 1 plus I sub 2. So I multiplied everything by S and I took this one to that side. Combine like terms, what do you have? 160,000 plus 20S times I sub 1 plus 20S times I sub 2 equals 48. That's my first equation. Not bad at all. Oh shoot. I got a class to go to shortly. Let me do I sub 2 here quickly. Yep. I sub 2 as a function of S. So here we go. 20 times I sub 1 plus I sub 2 plus 0.0064 S, that's an S, times I sub 2 minus 0.01536 equals to 0. 20 I sub 1 plus 20 plus 0.0064 S I sub 2 is equal to 0.01536. And that's my second equation. Let me jump in on my calculator and see what the answer is. Escape. Quit. Here we go. Two equations by two unknowns, new one. So what I have for the first one, what was it? 160,000 plus 20x. Next one is what? 20x, 48. Next one, 20 plus 0.0064x equals 0.01536. Solve. Busy. Here we go. I sub 1 as a function of s equals 7,500 over s squared plus 2s plus the 5. That's also not bad for inverse Laplace. And I sub 2 it's 2.4 over s plus 4875. Wow. S squared plus 8,000s plus 2.5 times 10 to the 7. What is that?
That's awful. I got like a gigantic.
Yep. And now you got to find the inverse Laplace. Well, once you find I sub 2, I don't have time to do it because my timer just clicked to remind me. My class starts in 5 minutes. My next class, I got to change room and close this shop here. So the way I would finish it, complete it, V out as a function of S will be 0.0064s times I sub 2. Subtract from it 0.01536. You know what I sub 2 is this number. Then what's the last step once you do that? Get the inverse Laplace of V out as a function of S. I'll say have fun with it. I would normally do it, but I'm running out of time. But you multiply this by that, subtract that number. Actually, my calculator probably will give me what that answer. No, do I still have it? No, I got out of it.
You can't do Laplace.
You can do the inverse Laplace on Mathematica.
Yeah.
Yeah. But not on this, or maybe this calculator does, I just don't know how.
You can probably do it like using the.
It does not do Laplace. You need to buy it.
You do?
Yeah, you can probably do it from the definition. Though,
You can do it from the
Integrated
definition.
Yep.
But
Pretend I did this.
it doesn't solve it for you.
Yeah, I wonder if you put in terms of definition of Laplace,
It'll do it that way,
you know?
sort of. Actually, I never tried it.
You gotta do it that way.
Yeah.